Today we will start with lesson 2, chapter 10, lesson 2, which is talking about areas of trapezoids, rhombuses, and kites. We will learn how can we find the area of the trapezoid, rhombuses, and kites. Now, let's start now with the trapezoid. The area of the trapezoid, as you see here, this is the trapezoid. We have this side, and this side also, and they are matching each other like this. And these two sides only are parallel to each other. Now, this is a trapezoid. For this trapezoid, how can we find the area? Let's name the side which is down with base 1, and this one, let's name it with base 2. So here we have two bases, and if you connect between these two bases with an altitude, this altitude we have to name it, or we have the length of this altitude is the height. So if I want now to find the area of the trapezoid, I need the length of the first and the second base, and also I need an height. This height is the length of the altitude that is between the first with the base 1 and the base 2 and perpendicular on them. I cannot use this height as an example, or this height. Yes, they are segments, they are connected, and it's connected between the two bases, but it must be perpendicular to each other. So now the idea from here now, that if I need to find the area of the trapezoid, I need the length of the base 1, the length of the base 2, and the length of the altitude. This altitude is an line segment that connects between the two bases and perpendicular on them. And the formula or the rule is A, the area it will be half the height times the summation of the base 1 plus the base 2. So the first step, I will add the length of the two bases, then I multiply it by half the length of the altitude, or half h. This is a way to find the area of the trapezoid.
Teacher?
Yes, Rose?
Teacher, but here the height is perpendicular only to base 1, right?
No, add it here also. Look here. Wait, please. It's perpendicular to both of them. Or you can use this one. I mean that it must be perpendicular to the two bases. Now, let's do problem number 1. In problem number 1 here, we have to find the area of the trapezoid. Here we have a Nevada. Its shape is a trapezoid. We have to find the area of this state. Here now, it's like this. Under 1, they are parallel to each other. Here we have this one. The length of the first base is 205, and the length of the second base is 511, and the length of an altitude that's connect between them and it's perpendicular, it's 309. So now let's find the area of the trapezoid. So the area now, it is half the height times the base 1 plus the base 2. Now then, where's the base 1? It is 205. Where's the base 2? It's 511 times half. Where's the height, H?
309.
309. There's the base 1, this is the base 2, and the height, which is 309 times half. Then after that, the first step, let's add 205 plus 511. The answer is 716. Then I multiply it by 300. Then I divide it by 2. So this number times 309 divided by 2.
It's equal to 358.
So the answer now, but with the final answer now, that the area of the Nevada was 110,622 miles squared. Is it clear?
Yes, teacher, thank you.
Let's have another question now. In this one here, he asked me now to find the area of the trapezoid with the height 7. So here we have trapezoid like this. The height is 12, is 7, sorry. The first base is 12, and the second one is 15. I need now to find the area of the trapezoid. So to find now the area of the trapezoid, we say that the area here is half the height times base 1 plus base 2. Where's the first base? It's 15. The second one is 12 times half. Where's the height? It is 7.
7.
So half 7 times 15 plus 12. Then 15 plus 12 is 27. 27, I multiply it by 7 over 2. 7 times 7 is
It's 94.5.
7 times 2 is 14 over 2. It is 9. 9 divided by 2 is 4.5. So 94.5. What is the unit now? It will be centimeter squared. Is it clear?
Yes.
Okay.
Yes.
Now, in this problem here, I'm sorry, just give me 1 minute. I forget to put the shape. Now, in this one here now, we have to find the area of the trapezoid, PQRS. Now, but here we have the first base, the length of the first base, the length of the second base, and also I told you we have a height. We need a height, but here there's no height. I have only an angle. Please give me 1 minute. sorry. So here now for this trapezoid, I told you if you want to find the area of the trapezoid, we need the length of the first base, the second base. So I need the length of two bases, and then the height of the altitude between them. So okay, I have the length of the two bases, but I don't have the length of the height. So what we have to do, or the length, sorry, of the altitude. The first step here, we have to draw a line or a line segments that connect, we name it with an altitude, that's 70 here, sorry.
Teacher, are you typing?
Yes.
Because I can't see you are typing.
Do you see the slides?
Yeah.
No, we see the page where there's bubbles.
We can use trigonometry.
Sorry?
I see the page.
Oh, okay. I opened the slides.
Teacher,
Oh. Now, did you see the slides?
Yeah.
Yeah.
teacher,
Yes, Lama.
can you admit Sarah?
Okay. Where is she?
Isha, I think she has a problem. She can't understand the
Okay. Hey. So here now, I will repeat. Here now we have a trapezoid. This trapezoid, as you see, it has two bases. And if I need now to find the area of the trapezoid, the area is half the height, base 1 plus base 2. So I need the two bases, and I need also the length of the height of the altitude that's perpendicular between them. The base 1 here, it is 5. And the second base here, it is 7. But I need to find the height. From where I bring the height? If we draw an altitude here, what did we have here now? Did I make a right
We're going
triangle?
to have a 30, 60, 90 special triangle. We can use trigonometry rules to find the height.
Yes. So did we have a right triangle? Yes. As you see here, the shaded one is a right triangle. In this one here, we have an angle which is 60 degrees. If I need now to find the length or the height of this altitude, I need another side. And look, now go back to the trapezoid. The length of this base is 5, and the length of this base is 7. So we have here a rectangle with 5 and 2. Is it right? Since we have a rectangle and the first base here is 5, so here it have to be 5 and 2. Is it right?
Yeah.
Yes.
Here we have 5. We have, after we divide this, or after we cut this trapezoid, we make a right triangle and a rectangle. The first one, we have a rectangle. If here is 5, so down it will be 5. So if this,
so 7 minus 2 will be 5.
Yes, 7, so here it will be what? It will be 2. So here now I have 2. Then, as now Susan said, we have to use now the sine, cosine, or tan to help me now to find the missing altitude. Let's name it with x. Now, I have opposite over adjacent. And the opposite over adjacent, is it a sine or cosine? Tan. Tan.
It's 10, but there is a rule we can use that says that the long leg is the square root of 3 multiplied by the short leg.
It's in the 60, 36.
No, here I want you to use this way, because another examples, it's easier for you to use this one. Okay. Because here we have 60, you can use this one, but later on, if you have another angles, we have to use the trigonometry. Yes, miss.
Teacher, I don't know what happened. They told me there was an error and the call ended.
Did you see this slide, or did you see what's the last things you learned to talk about it?
Problem 2, I didn't see it.
Okay, I just started it. I'll repeat it for you now. Here now, Sarah, we have a trapezoid. In this trapezoid here, okay, in this trapezoid, I need to find its area. And I told you to find the area of the trapezoid, I need the first base, the second base, and also the height. So the first base is given, it is 7, and the second base is 5. But where's the height? To find the height, I need now to draw an altitude. This altitude, it makes this shape into rectangle and right triangle. Here we have a rectangle, and here we have a triangle. Now, let's look at the rectangle. In the rectangle here, this base is 5, the first base or the second base. And here, it will be also 5, because they are parallel to each other. And then under this altitude is 5. So from here to B, we have 2. Since that 2 plus 7, 2 plus 5 is 7. So now the base of the triangle now is 2. Why I use this way? Because I have an angle. I have this number 2, which is a base of the triangle, and I need now to find the unknown altitude, the height of the altitude. How can I find it? I say that for this angle, we have an opposite over adjacent. The opposite here, it is x. The adjacent here, it is 2. And the angle here that I have, it is 60. So I will say now, tan 60 is x over 2. Then 2 tan 60 is equal to x. Now, what is the value of tan 60? We know that you can find by calculator, but tan 60, you know that the tan is sine over cosine. So the sine of 60, it is the square root of 3 over 2. And the cosine of 60 is the same as sine of 30, so it is half.
30, so it's half, yeah.
So tan 60 is square root of 3 times 2. So the length or the height of the altitude is 2 square root of 3. So the height here, it will be now 2 square root of 3. Then I multiply it by half. Is it clear?
Yes.
Yes.
Yeah.
Okay. So then after that, let's go back now here. 2 cancel, 2 cancel 2. So it will be square root of 3 times 12. So the area of this trapezoid is 12 square root of 3. This is the answer of the area of this trapezoid. what is the unit here? Meter squared. We have more examples. Let's do another one. Let's do now first number 18. Then we go back to 17 and 19. In number 18 here, we have the same idea. Here we have this is number 18. Here we have now this trapezoid. And for this trapezoid, the length of the first base is 15. And there's nothing known about the second base. There's nothing known about the height of the altitude. He just told me that the angle here is 60 and the length of the hypotenuse here is 8 feet. So here, I want to find the area of the trapezoid. So the area now of the trapezoid, it is half height base 1 plus base 2. And I want to find the area, but I don't know anything about the height, and I don't know the length of the base 2. So I need now to find the length of the base 2 and the height. Both of them I need to find.
We can use trigonometry here too.
So here now we have to use the trigonometric. Here we have a 60. For this 60 now, I want this angle. It's helped me now to find the length of the altitude. Let's have, I want now, we don't know what we have to use, sine or cosine or tan. For this one, let's name it with h. For this angle 60, I have an opposite to the angle over the hypotenuse. And opposite over hypotenuse is sine. So I have to write down here sine. Then sine 60 is opposite, which is h, and the hypotenuse, which is 8. And sine 60, it is square root of 3 over 2 equal h over 8. Let's write it as square root of 3 over 2 equal h over 8. Then by multiplying 2h, it will be 8 square root of 3 divided by 2. Divide by 2, so h now is 4 square root of 3. Is it clear?
Yeah, and now we can find the short leg and subtract it to get the other base.
Yes, but how to find the height, is it clear?
Yes.
Yeah. Yes.
So here the height now, it is 4 square root of 3. Now what do I need also? I need the height, I need also the second base. Okay.
Teacher, if here we use the sign, why the other one we didn't use the sign? Because it was to the hypotenuse, not to
When?
the opposite side.
Where?
And problem 2.
In
It was
problem 2,
opposite
no,
to the
I don't have the
hypotenuse.
hypotenuse. I have the adjacent.
Yeah.
It was here, the number. Sorry. The number, it was here. Sorry. No. The number, it was here. This is the adjacent. That's I used tan. Now,
Okay.
Now I need now to find the length of the base. To find the length of the base, I need this one. Let's name it with B. Okay. How can I find it? the length of the second base here is 15. So if I know now the length of y, which is the base of this triangle, can I say 15 minus y equal b?
Yeah, we can.
Yeah, okay. Can I get 10?
Yeah,
حنين.
teacher.
Yeah.
Yeah.
No, حبيبة. Can I?
Yes.
Because y plus b equal 15. So to find b, we have to find the y. And also we have to use the trigonometric function. Here we have now, for the angle 60, here we have the adjacent y over the hypotenuse as an example. Or if you choose adjacent over opposite, it will be the same. Now adjacent, which is y, over the hypotenuse. Is it sine or cosine?
It is
Cosine.
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 Yes, adjacent over hypotenuse, it is a cosine. So cosine, the angle here is 60. Now then, cosine 60 is the same as sine 30, so which is half.
Or half. Yeah.
What is the adjacent of the angle 60 here?
Y.
Is y over the hypotenuse
8.
8. Then 8 equal to y, so y now.
So Y equals 4.
So now
B is equal to 11.
yes, here now we have a 4. So let's do it now. As like this. The length of the pink one is 15. And the length of the white one is 4. So what is the length of
11.
the pink one? It will be 11. Is it right?
Yeah.
And since here now is 11, and we have a rectangular where every two parallel sides have the same length, so B it will be 11 also. Is it clear?
Yes.
Okay.
Yeah.
Yes.
Yes.
So now I have the height, I found the height, I found the base 1, or I have the base 1, I have the base 2. I can find now the area of the trapezoid. So now the area of the trapezoid is half 4 square root of 3, base
Plus
1
11.
15, base 2 11. So it is 2 square root of 3 times 26. So the answer is 52 square root of 3 feet squared. This is the area of the trapezoid in number 18. Is it clear now?
Yes.
Okay. Now, all of us know the Pythagorean theorem. In the most common triangles, it was 3, 4, 5, 6, 8, 10, and 5, 12, 13. Do you know them?
Yes, teacher.
Here now, the first one. If you use the Pythagorean theorem, 3 squared plus 4 squared, it is 25. Under the square root, it will be 5. The second one, 6 squared plus 8 squared, which is 100. The square root of it will be 10. 5 squared, it is 25. Plus 144, it is 169. The square root of it is 13. So now, look at number 17. In number 17 here, we have this trapezoid. Here we have 6. Here we have a 3. Here we have 5. And I need now to find the area of the trapezoid. So, to find the area of the trapezoid here, we said it is half height B1 plus B2. Now, where's the height here? I need the height. Look at this triangle.
It's Pythagorean theorem.
You can use the Pythagorean theorem. You say it 5 squared equal 3 squared plus x squared, and after that you will find that x is equal 4. Or you can use the triangles that I give it to you here. If the base is a 3 and the hypotenuse is 5, by the way, this not happen only if the hypotenuse is 5 and the two legs are 3 and 4. If they have a different order, like the hypotenuse is 4 and the two legs 3 and 5, it will not happen. Only if the hypotenuse is 5, the base is a 3, and so the height here, it will be 4, using this triangle. Is it clear?
Yeah.
So
Yes, teacher.
the height here is 4. Now, here the length of the first base is 6. What about the length of the second base now? If it is rectangle, so if here is 6,
It should be 6.
what is the length of the second one? It will be 6 too. But 6 is it's the length of
9.
9 segments. So I need the length of the larger base. This one.
It
So
will
what
be
is the length?
9.
It will be 9. Is it clear? Then, after simplifying, 2 times 15 is 30. By the way, this chapter 10 and chapter 11, and inshallah we'll talk on another chapter, they are in the final. I'm starting now with the
Teacher,
material
is it in the
finals.
final?
Yes?
We'll finish, يعني?
Sorry?
We're going to finish.
Not now. some طولين. بس this is the material of the final. Now, the conic sections to the third quiz. This now, the final. Yeah, let's continue now. So here we have, by now we find the area of the trapezoid. Is it clear?
Teacher, can you say again from where you bring the 9?
Here is the 6. And since it is a rectangle, and in the rectangle, each two parallel sides are congruent. So if here is 6, here it will be 6. And here is 6, here it will be 6. Now this 6 is a length of the line segments from here to here for the rectangle. But is this the base of my trapezoid? No, the base is from this side to this side. This is the base. So what the length will be? It will be 6 plus a 3.
Oh, okay. Thank you, teacher.
Okay, you're welcome. Now let's see number 18. In number 18 here, we have 10, 8, 6. We have now to find the area of the trapezoid. If we have here 8, now this is, you can use the triangles that I gave it you before, or you can use the Pythagorean theorem. Let's name it with x. I need now to find x. To To find x here, I said 10 squared is equal 8 squared plus x squared. Then after that, you will find that x is equal 6. I have only 1 minute. I have to finish this question. So x here is 6. It's okay now. I have the height. Yes, it is 8. The height is 8. It is given. The base 1, it is 6. What about the base 2 now? What about the base 2?
It is 6.
From this side,
It's 5.
this side, it is 6.
Going to be 6 plus
And
6.
since we have a rectangle, since we have a rectangle, here it will be also 6. So what is the length of the big base?
12.
It will be 12.
It's 12 because 6 plus 6.
So the length now of the base is 12. So because of that, I will say now that the area will be half the height, which is 8, times the base 1, which is 6, plus the base 2,